Assalamu alaikum, ma'am. How are you?
Hello, Assalamu alaikum. Are you all able to hear me?
Yes, ma'am.
Okay, how is everyone?
Alhamdulillah. How are you, ma'am?
I'm good, Alhamdulillah. Okay, so today we're going to begin with redox reactions. We were doing redox, I believe. Let me just share the screen with you. Wait a minute. Okay, so in redox reactions, basically redox reactions are those chemical reactions which consist of oxidation and reduction reactions both. Okay, so such a chemical reaction where oxidation reaction and reduction reactions, both of them, they are taking place simultaneously. They are referred to as redox reactions. Now, we did electrochemistry and we did reactions at the electrodes. And both of those reactions at the electrodes which were taking place, they were either loss or gain of electrons, and which is why we say that electrolysis is a very good example of redox. Because oxidation and reduction, both of them, they are simultaneously taking place at both of the electrodes, that is your cathode and the anode, which is why we say that electrolysis is a very good example of redox reactions. Now, when we particularly describe oxidation reactions and reduction reactions, they can be described in terms of either electron transfer, gain or loss of oxygen, gain or loss of hydrogen, or the oxidation state. Okay. So oxidation state, you can also say, is also just like valencies. For instance, if a particular atom has loses or gains an electron, it is going to get a number which is going to be referred to as the oxidation state of that particular species. Now that oxidation state, basically, hence we can say that it completely depends upon how many numbers the particular species has gained or it has lost. Okay. Oxidation in terms of electron transfer is loss of electrons. Okay. So any species which is losing its electrons is meant to be, or that particular chemical reaction will be referred to as oxidation reaction, right? For instance, I say that you have sodium atom loses an electron and forms sodium ion, right? So this is going to be an oxidation reaction. We are going to say that sodium has been oxidized, not sodium ion. Sodium has been oxidized to form sodium, as a result of which we say that this is an oxidation reaction. Okay. But supposingly, if I reverse it back, I say that sodium ion gains an electron and it forms sodium metal. Now, in this case scenario, this sodium ion is another species. Okay, this is sodium atom, which is completely different, and sodium ion is completely different species, right? So these sodium ions, they are going to gain electron, as a result of which they form sodium metal, and gaining of electron in electron transfer is referred to as reduction reaction. So we say that gain of electron is going to be reduction. Loss of electron tends to be oxidation, and we remember it from the mnemonic of oil rig. Oxidation is loss and reduction is gain of electrons. Okay. Is this point clear up till yet? If anyone has any questions, please do let me know. Okay. Moving on. Oxygen, in terms of oxygen, oxidation is gain of oxygen, reduction is loss of oxygen. For instance, you have iron. Iron is oxidized it reacts with oxygen to produce its own oxide, supposedly Fe2O3 or FeO. Okay, so this is going to be your oxidation reaction. Okay, whereas reduction is loss of oxygen. If any particular species is going to lose its oxygen, and so hence we say that it has been reduced. For example, I have copper and copper oxide and zinc. Zinc being the most reactive out of all the metals, it is going to steal away the oxygen from the less reactive metal, that is copper, as a result of which we get zinc oxide and copper, right? Now, if I ask you, tell me which of these metals has been reduced or which of them has been oxidized in this particular reaction. Copper oxide reacts with zinc to form zinc oxide and copper. Yes, I am.
Ma'am, zinc has been oxidized and copper has been reduced.
Yes, very good. And what is your explanation going to be?
Because copper oxide has lost its oxygen and it has been gained by the zinc.
Yes. So this, yes, very good. So this is going to be your explanation for the answer that copper oxide is going to be oxidized. If they ask you which species is oxidized, they give you underlined species in MCQs specifically. So they asked you which of them has been oxidized. Either they are also going to give you copper oxide and they will also underline copper. But you will say copper oxide is reduced, okay? And zinc has been oxidized, okay? Not zinc oxide. Zinc has been oxidized to form zinc oxide. Copper oxide has been reduced to form copper. Okay. Moving on. Yes, I am.
Ma'am, you did this Na plus electron gives us Na. So, ma'am, we should say that sodium ions had been reduced, right? Not like sodium
Not the
has been
sodium
reduced.
metals. Yes, yes, exactly. Okay, next up we have hydrogen. Now, hydrogens, if they are lost, okay, we say that an oxidation reaction has taken place. And in terms of hydrogen, reduction is similarly gain of hydrogen, okay. Oxidation state. This is very important because usually when you will be asked to describe or explain your reasoning, it is better off, or usually they ask you in terms of electrons, in terms of oxygen, in terms of oxidation states. Okay. So oxidation, in terms of oxidation states, the oxidation number is going to increase and the oxidation number decreases in reduction reactions. As the term suggests, oxidation reactions are those reactions where oxidation state or oxidation number of the particular species is going to increase, and reduction reactions, the oxidation state is going to decrease. Okay. For instance, you have supposingly, let's take, did we do the rules last time? I think we did some rules for these. Do you guys remember the rules for oxidation states?
But I don't think we've done the rules.
Okay. Okay, let's discuss them. So whenever we are talking about any particular, let's just take a quick example of it and then we're going to discuss it. For example, let's take the same copper oxide reacts with zinc to form zinc oxide and copper. When any elemental form is present, okay, any element which has yet not combined with any other element, its oxidation state tends to be 0. So in this particular reaction, I can say zinc is in its elemental state. It has yet not combined with any other element. Okay. Copper is also in its elemental state. So we are going to say this is also again going to be 0. The oxidation state of copper and zinc tends to be 0. Okay. Now there are certain common oxidation states for some groups. For example, group 1, group 2, group 3, and group 6, group 7, they tend to have common oxidation states. For example, how can you determine by looking at the group number, what the common oxidation state is going to be? For example, if I say that you have group 1 element, like lithium, sodium, or potassium, they have a greater tendency, that is to lose electrons. So its valency is going to be +1, and this ion is referred to as a monoatomic ion. Mono means 1. Okay, this is a monoatomic ion. Mono means 1, and whatever the valency or the charge they get, okay, this is going to be its same oxidation state, that is going to be +1. Okay, this is referred to as a common oxidation state. Similarly, if you have chlorine is present in group 7. So there is greater tendency that it is going to gain 1 electron, by which it is going to have a negative charge. This negative charge is actually going to be its oxidation number, which is going to be -1. This does not mean that in some specific cases or exceptional cases, there in chemistry, you have lots and lots of exceptions. So sometimes what happens, this is a bigger concept. So just stay with me. So for instance, if you have there are electronegativities. For example, you have 2 different elements, 2 different atoms which are present in a particular compound. And this compound has, both of these elements, they have different varying electronegativities. Now, what is electronegativity? Electronegativity means that a particular element has a tendency to attract the shared pair of electrons towards themselves. Let me repeat myself. When the atom has greater tendency to attract the shared pair of electrons towards itself, this means that it is more electronegative. And out of all there are electronegativity values which are placed in the Pauling's scale of electronegativity table, which determines what electronegativity power is for each and every different element. Now, in this particular, this is an exceptional case. Okay. So fluorine has the greatest electronegativity as compared to oxygen. Why am I telling you this? Because this is going to be linked towards the oxidation numbers of common and the exceptional cases. So fluorine is going to retain its original original oxidation number, and oxygen is going to become, since we know oxygen tends to have, what is the common oxidation state of oxygen? Can someone tell me? Yes, Zoya.
-2.
-2. Now here we would think that oxygen is going to be -2 here. Okay. And fluorine should be something else. It should be maybe -1, but both of them, they cannot be negative, right? So in this case scenario, when both of the elements, they have different electronegativities, and the one which has greater electronegativity as compared to the other one will retain its oxidation state. So fluorine retains its oxidation state, that is -1, and oxygen is the one which is going to become positive. So if you solve this one, if you solve this whole compound's oxidation state, the complete compound as a whole has a sum of oxidation states which tends to be 0. Okay, their summing up of the oxidation states tends to be 0. Here, fluorine will get -1. As it is most electronegative, so it is going to retain its oxidation state. And oxygen's oxidation state is unknown to us, so I'm going to place X here. And I said that both of their oxidation states should be summed up to give me a total of 0. This is only true for the compounds. This is only true for the compounds. Compounds do not have an overall charge. Okay. So here in this case scenario, this should be -2. To get a total of 0, this must be +2. So oxygen is not going to be -2. However, it is going to be the positive. So the less electronegative atom or the element, which is the atom which is present within a particular compound, is going to become positive in its oxidation state, and the other one is going to become negative in the oxidation state, and that is solely because of the electronegativity difference in the electronegativity values of the two. Is this point clear so far? Yes, Zoya.
Miss, how will I know exactly which element has a greater electronegativity?
From the Pauline's scale. And if, for instance, if it is usually Pauline's scale is not given to you in your exam paper. This is an exceptional case to make you understand the difference of the common oxidation states and varying oxidation states. Some of the exceptions you must know at this point in time. For instance, oxygens in peroxides like hydrogen peroxide or any other peroxides, they tend to have an oxidation state of +1. Okay. In hydrides, they, for instance, sodium hydride, hydrogen tends to have an oxidation state of +1, but in hydrides, their oxidation state will be -1. Just jot down these points somewhere. I will also give you the cumulative basic collective paper of this one, which has all the material regarding this topic. I will upload it on Google Classroom as well. But for instance, if it is not given, they will be mentioning it in your in the question paper. Okay. Usually, this is not asked, but to make you understand, I'm telling you the exception. Okay.
Okay, Miss.
Okay, let's go back. So up till now, we basically discussed that redox reactions, they are those reactions which have oxidation and reduction reactions taking place both simultaneously, which is why the collective reaction is referred to as a redox reaction. If I say that answer me whether this particular reaction is a redox reaction or not, then you have to compare that whether the reaction has oxidation and reduction reactions both taking place at the same time. Okay. And these can be referred to and they can be explained in terms of gain or loss of electrons. Oxidation is loss of electron and reduction is gain of electron. And we see this in electrolysis. Gain or loss of oxygen, whenever oxygen is gained, it is meant to be oxidation reaction. Whenever it is lost, it is meant to be a reduction reaction. Then we said that in terms of hydrogen is loss of oxygen and loss of hydrogen is oxidation reaction and gain of hydrogen is a reduction reaction. Oxidation states they tend to increase in oxidation reaction and in reduction reaction, oxidation state is going to decrease. So the rules of the oxidation states are that the element, whenever that element is not combined with any other element, for instance, these two, here in this case scenario, they are going to have an oxidation state of 0. Other than this, you have molecules. For example, oxygen, it is a molecule. It is still in its elemental state. It is not combined with any other element, so its oxidation state is going to be 0. Chlorine, again, it is a molecule. Hydrogen, nitrogen, fluorine, any other molecule, if they are in their elemental states, they are not yet combined with any other element, then their oxidation states, they tend to be 0. Okay. Then we discussed about monatomic ions. Monatomic ions are those ions which have, they are single atoms and mono means one. So only one particular atom has been ionized. So for instance, if I say sodium ion, Na+, this means this plus charge is going to be telling you what will be the oxidation state. So its oxidation state is going to be +1. Chloride. Chloride has -1 as its valency, so it is going to be -1, the oxidation state. Oxygen's oxidation state is going to be, oxide ions oxidation state is going to be 2 minus. Why? Because it is present in group 6 of the periodic table, which means that it has a greater tendency to gain 2 electrons, right? Now, coming back, next I said that if you have compounds, in compounds, what happens, for example, copper oxide or zinc oxide. Since we said that some of these species, they tend to have the same oxidation state, that is the common oxidation state. So oxygen here is going to have -2 oxidation state. This means that oxygen has not actually undergone any reduction or oxidation. Yes? Do we all agree with this? Oxygen, has it undergone reduction or oxidation, do you think? Yes.
Yes, because it hasn't got under reduction or oxidation.
Yes, it has neither undergone any oxidation nor any reduction. Why? Because the oxidation state has not changed. It is still -2, right? Now, when I said that a particular compound is going to be having a summing of their oxidation state is going to be collectively 0, which means that this number should be balanced by the oxidation number of copper. So it is going to be +2 here. +2 and -2 is going to become 0. So copper's oxidation state is +2, and it has changed from +2 to 0. Are you guys able to identify this? Tell me, is this oxidation state increased or it has decreased from +2 to 0? Yes, Ayan.
Decreased.
Decreased. So whenever the oxidation state decreases, we say it is a reduction reaction. Okay, this is a reduction reaction. Now let's look into the next counterpart. The next one says you have zinc. Zinc was 0 at first, but in zinc oxide, what is the oxidation state of zinc in zinc oxide? Yes, Ayan.
+2, +2.
So here, do you recognize, do you identify that is there an increase of oxidation state or decrease?
Increase.
Increase.
0
And
to 2.
yeah, whenever we have an increase of oxidation state, we say that it is oxidation. So thereby, we are able to suggest that the increase in oxidation state by +2 tends to mean that this is an oxidation reaction. And which species has been oxidized? Zinc has been oxidized to form zinc oxide. And copper, it has decrease in its oxidation, decrease in its oxidation state. So it is going to be reduction reaction. And it is, hence we say that copper oxide has been reduced to form copper. So copper oxide is reduced. Zinc is oxidized. Okay. And since both of the reactions are simultaneously taking place within in this, which is why we say that this particular reaction is going to be your redox reaction. Let's do some more examples. Yes, any questions by far?
Miss, in the previous equation, how did you get +2 as zinc charge?
In wait a minute, let me scroll it up. Yes, which one are you asking?
Zinc oxide. How did you come to get +2 as zinc charge?
+2, because this is going to be, let me show you another way of doing this. So for instance, you have zinc oxide, and we said that the summing up of any oxidation states which are present in a compound, it has to be a total of 0. So oxygen's oxidation state, common oxidation state is -2. Why? Because it is present in group 6. Group 6 means that it is only going to gain 2 electrons. If it is going to gain 2 electrons, it is going to have a charge of -2, right?
Yes, ma'am.
Shall I repeat myself?
No, I understand it.
Okay, so -2 is the common oxidation state of oxygen. Now I say that this zinc is, I don't know what's the oxidation state of the oxidation state of zinc. So it's x plus minus 2 equals 0. All right. You're going to either do elimination reaction or just shift minus 2 to the other side to give you plus 2. So zinc's oxidation state hence tends to be plus 2. Okay.
Okay.
All right. Next, we have, whenever we have polyatomic ions, for example, you have sulfate. It is SO4 2 minus, carbonates, CO3 2 minus, phosphates, PO4 3 minus, okay? Or any other hydrogen carbonate or any other polyatomic ion. The total or sum up of that polyatomic ion has to be equivalent to the overall charge that they have. For example, let's take sulfate here. So in sulfate, you can see that the overall charge is minus 2 here. Since it is a polyatomic ion, polyatomic means that there are multiple atoms which have combined together to form an ion, and the overall charge, they have an overall charge. Okay. So in compounds, the summing up of the oxidation states of the atoms tends to be 0. But in polyatomic ions, it has to be the overall charge. Okay. So minus 2 is written here rather than instead of writing 0. Okay. Sulfur, supposingly we say that let's find out the oxidation state of sulfur. So I'm placing X here. Oxygen, how many oxygen atoms do we have? 4. So 4 times the oxidation state of oxygen, which is going to be minus 2. And then you're going to solve it. So X is equals to minus 2. And 4 times minus 2 is minus 8. When it goes on the other side, it becomes plus 8. So X is equals to plus 6. This means that sulfur's oxidation state here is going to be plus 6. Other story, to cut it short, another way of doing this is if you simply are good with mental math. So oxygen's oxidation state is minus 2, but minus 2 times 4 becomes minus 8. I have to get such a number here with sulfur to get a total of minus 2 as the overall charge. This means it has to be plus 6. Plus 6 and minus 8 will give you minus 2 as the overall charge. Are we all good? Is this point clear so far?
Yes, miss.
Okay, let's do another one. So transition elements, they tend to have varying oxidation number, right? They have, when you're going to go in AS chemistry, you're going to understand this concept much better. But for now, just you should know that transition elements, they tend to have variable oxidation states. This means that they have a tendency to either lose 1 electron, 2 electron, 3 electron, 4 electron, maybe 5. Okay. So they have variable oxidation states like manganese. Manganese even has plus 7. It also tends to have plus 2 oxidation state. Okay. And because of these variable oxidation states, they have their colored compounds, they change. Yes, I am.
Ma'am, for the elements in group 4 of the periodic table, what will they do? Gain 4 electrons or lose 4 electrons?
They usually tend to lose 4 electrons, but they also sometimes gain 4 electrons. But most of the time, they lose 4 electrons.
Okay.
Hmm.
So, like, is it based on like non-metallic or metallic?
Yes,
Like,
yes,
if it's
because
a
they
non-metallic,
are, yeah, we're going to look into in more detail in periodic table. Group
Oh.
4, they basically are semi-metals. They have characteristics of both. They are referred to as metalloids because they also have characteristics of metals and also have characteristics of non-metals, which is why they are present in literally between both of the metals and the non-metals. Yes. Okay. Whenever we are writing in for transition elements, we write cobalt, for instance, and 2 chloride. Okay. All right. Now this Roman numeral 2 helps you determine that this is the oxidation number of cobalt. Okay. The transition element. For example, it can also be copper 2 sulfate. This means copper has an oxidation state of +2. Again, it could be copper 1 oxide or copper 2 oxide. This means the Roman numeral is referred to as the oxidation state of the transition element which is written before it. Okay, so here cobalt 2 chloride, this means that this 2 is basically the oxidation state of the transition metal cobalt here. This also means that chloride ion is going to be -1, and since there are 2, so it's going to be -2 as a total, and the cobalt is going to be +2 here. All right, so total of this will become 0 as a result, the summing up of their oxidation states. Okay. Then there is one more concept I want to give you here about the reducing agents and the oxidizing agents. First, tell me, in this particular reaction that I'm writing, which species are oxidized and which one are reduced? And whether this reaction is a redox reaction or not. Yes, Ayan.
Okay, ma'am. So this is a redox reaction, and iron oxide is being reduced because it loses its oxygen, and carbon monoxide is being oxidized
So why?
because it gains the oxygen. That's why.
Okay.
And iron oxide loses the oxygen.
And which iron oxide is this?
Which iron
Iron
oxide?
2, iron 2 oxide, iron 3 oxide.
Iron
What
3
is
oxide. Yes.
iron 3
3
oxide?
oxide.
How do we get to know the oxidation state of iron here?
Because I saw the like, you do the cross multiplication, and so you get. I saw the 3 in front of the oxygen, so I thought that it would be +3. And oxygen has -2 charge, so when we cancel out, like do the cross multiplication, so we get this charge.
Yes, so here you basically have -2 as the oxidation state of oxygen, and this is going to become -6 as a result. And iron, if you see that it is X, you need to multiply it by 2 since you have two iron atoms here. And when you're going to solve it, you will get to know that this is basically 2. This needs to be +3. So +3 times 2 is going to become +6. Okay. And this is going to basically become equivalent, which is why we say that the summing up of their oxidation states is going to be 0. So iron here has changed its oxidation state from +3 to what is
0.
the change? 0. Okay. And here oxygen is again -2 and carbon is carbon is
+2.
+2. Okay. So this carbon is basically +2. It has greater tendency to get oxidized. Okay. As a result of which the oxidation state of carbon changes from +2 to +4, and oxygen's oxidation state still remains the same. Here we say that iron has been reduced, its oxidation number has decreased. Okay. And here carbon has been oxidized, its oxidation number has increased. So we say that carbon monoxide tends to be a very good reducing agent. Okay. Carbon monoxide tends to be a very good reducing agent. Now you have to don't mix these things up. It's very easy, very simple to learn that whenever you have any substances which are undergoing oxidation reaction and reduction reaction, okay, whenever there is any such substance which is undergoing oxidation, it is going to be the opposite. Okay, the one with the species which is basically undergoing the species Are you guys able to view the OneNote? No?
No, ma'am. The screen stopped sharing.
Okay. Is it visible now?
Yes.
Okay. So I was saying that whenever you have any particular species which is undergoing oxidation reaction, it is going to be the opposite. It is going to be in agents, it is going to be reducing agent. And the one which is getting reduced, it is going to be the opposite. That means it is going to be the oxidizing agent. Now, to basically describe it, what is a reducing agent and what is an oxidizing agent? Reducing agent, they are such species or such substances. What is the basic phenomena of agents? Agents, they tend to facilitate, right? So the one which is basically the species which is a good reducing agent, it is going to facilitate the other species in the reaction to get reduced, which is why we say that iron is reduced to from iron oxide, it has been reduced to form iron. And in the next case scenario, we see that we see that
Ma'am, the screen stopped sharing again.
yes, I'm sharing it again. Yes, is it visible now? Okay,
Yes.
so I was saying that reducing agents, they are those agents which are going to facilitate or they're going to help the other substance to get reduced, which is why we see iron gets reduced. Okay, iron oxide gets reduced to form iron. However, oxidation states are those substances, oxidizing agents are those agents which are going to facilitate the other substance to get oxidized, and they will themselves get reduced. Obviously, that they're facilitating the other substance, they must be either they are going to they will be gaining electrons and they will be facilitating the other substance to lose electrons, right? So how are they going to gain electrons? Obviously they need to steal away electrons from the other substance. In other ways, we can also say this. So you have to correlate and link all of these concepts. You've got these basic concepts. These concepts, they are completely available in every other lecture. You can also look into any other books. But correlating all of these concepts is very important, which is why these classes, they are conducted. Okay. So what do I mean by that? I just said that iron is going to be a good oxidizing agent. And why is that so? This means that it needs to be reduced, which also means that it must undergo gaining of electrons. Can someone tell me how many electrons iron from iron oxide has gained to be reduced?
3 electrons.
3. Very good. Very good. Excellent, Rayan. So iron here, it has gained 3 electrons because the oxidation number has increased from +3 to 0. This means that it has undergone reduction reaction, and those are only going to undergo reduction reactions which are good oxidizing agents. Then of this also means that the other counterpart is going to be reducing agent. It is a good reducing agent since it is going to undergo oxidation reaction, okay, which means that they must be losing electrons. And here in this case scenario, this carbon has lost 2 electrons. Okay, one particular carbon atom has lost 2 electrons, which is why the oxidation number has increased from +2 to +4. Are you all able to connect these dots?
Yes, miss.
Okay. Is this concept too difficult to understand? Any questions by far?
All good.
All good? Okay. So in half reactions as well, you can also, for example, if you take this particular reaction, okay, You can also use this to form your half equations, which are going to be complete ionic equations. Complete ionic equations, they tend to have simply the ions without any electrons. Half equations, they have electrons. Okay, so I can say that copper, this is 2 plus in copper oxide. It reacts with zinc to form zinc 2 plus and copper metal. Okay, so this is the ionic equation. But if I say and I write it down as ionic half equations, this is going to mean that copper 2 plus gains 2 electron to form copper, which is reduction or oxidation.
Oxidation.
Reduction.
Gaining of electrons is reduction or oxidation. Yes.
Reduction.
Yes, reduction reaction. Reduction reactions, they are gain of electrons, and oxidation oxidation reactions, they are loss of electrons. So the second one is oxidation reaction. The first one is reduction reaction here in this case scenario. Okay. All right. Let me just looking for. For example, I'm going to take questions in a bit because very less time is left. So I'm just going to take your questions. Look at this one. Tell me, identify which ones are going to be oxidizing agents and which one is the reducing agent here. Yes. You can answer, write your answers in the chat box so I may know your responses. Which one is the oxidizing agent and which one is the reducing agent here? Okay, so Ryan is saying hydrogen is the oxidizing agent. Why hydrogen is the oxidizing agent?
Because it gains oxygen.
So the one who's gaining oxygen is the one which is being oxidized. In agents, they are going to be opposite. So it has to be the reducing agent. Okay. A common example of this is that a good reducing agent, they are group 7 elements, group carbon elements, and hydrogen. All of these, they are common examples of good reducing agents. One more example of this is potassium iodide. As we go down group 7, okay, the tendency of being a good reducing agent increases. This means potassium iodide, the iodide in potassium iodide compound is going to be a very, very, very good reducing agent. Okay. As compared to any other group 7 ion, for example, bromide, chloride, fluoride. Okay. All of them, their tendencies of being a good reducing agent is going to be less as compared to iodide. As I said that as we go down group 7, the tendency of being a good reducing agent increases. So potassium iodide, they tend to have, they are very good reducing agents and their color changes. Potassium iodide is colorless. Okay. In aqueous potassium iodide, it is completely colorless. But when it is going to undergo oxidation reactions, okay, it is going to get oxidized to form iodine. This means that, let me just write it down here as well. So I say that you have potassium iodide, okay. It reacts with some other substance, and as a result of which it is going to produce iodine. You will see brown or purple vapors of iodine, okay. In aqueous state, it is brown in color. In gaseous state, iodine is purple, okay. But in potassium iodide and aqueous potassium iodide, it is completely colorless. So this color change is observed to identify that this iodide ions, they have been oxidized, which means that potassium iodide is basically a good reducing agent. Here iodine has 0 oxidation state, here it is -1. There is an increase in oxidation state, which is why we say that it is an oxidation reaction. Are we clear?
Yes, Miss.
Okay. Then here, coming back to the previous reaction, here in this case scenario, copper was +2. From +2, it has undergone a change of oxidation state to 0. Here, it was 0, and this is now going to be +1, right? This means that this is an increase in oxidation state. It is oxidation reaction. Carbon, hydrogen, and group 7 elements, they are good reducing agents. So this is going to be reducing agent. And copper, since it has undergone a decrease in the oxidation state, which means it has been reduced, it is going to be the oxidizing agent. And always, both of them, they cannot be oxidizing agents. Okay. The strengths of losing and gaining of electrons, the strength with which they are going to lose or gain electron, identifies or determines which one is going to be the oxidizing agent and which one is going to be the reducing agent. Okay. If one particular substance, supposedly I say that hydrogen here is very good reducing agent, then, but I also say that copper oxide is also a very good reducing agent. Okay. But I will be then comparing their strengths to identify which one is a strong reducing agent. And in that case scenario, that particular substance is going to be the reducing agent and the other one is going to become the oxidizing agent. Okay. Similarly, concentrated sulfuric acid. Concentrated sulfuric acid is a very good oxidizing agent, okay, as compared to these potassium iodide. Potassium iodides and any other group 7 halide ions, they are all reducing agents. Similarly, likewise, we have oxidizing agents. Good oxidizing agents, they are hydrogen peroxide, okay. They are very good oxidizing agents. We can also say that group 7 elements at the top, fluorine is also a good oxidizing agent. Okay, it is a bad reducing agent, but it is a good oxidizing agent comparatively. So this is it for today's session. Let me know if anyone has any questions by far. Yes. Yes, Oya.
Miss, the ionic equation that you've written above, I don't understand how you wrote it.
Okay. This one?
Yes. This
Okay,
one.
so I said that this is copper oxide and this is zinc, supposingly. Or you can also say take copper sulfate and zinc. Okay. The spectator ions, which are the common ions on both the sides, they are cancelled out. So this is going to be oxide, and oxide was both the same at both the sides, which is why we cancelled it out. Spectator ions are only cancelled out. Okay. You can also separate these ions to actually identify which ones are which. Then the leftover ones, they are written as it is. So Cu2 plus is not same as Cu, right? Which is why we cannot cancel it out. Zinc metal and zinc ion is not same on both the sides, so we cannot cancel it out. This is going to be your ultimate reaction, which is your oxidation reaction, which is your redox reaction. Okay. And for the half equations, you're going to look into that. You will be adding in the electrons. Okay. So copper 2 plus ions, for example, I say this is copper 2 plus ions, and copper 2 plus ions, they are going to gain obviously 2 electrons, which is why they will be reduced to form copper. And zinc is going to lose 2 electrons, which is why it is going to become oxidized to form zinc 2 plus ion. So this is going to be the half equation, and the top one, which has all the ions without any electrons, is going to be your ionic equation, whole complete ionic equation. Are we clear?
Yes, miss.
Okay. Before, does anyone else who has any questions by far? No more questions? Please write down your attendance in the chat box and then you may leave. Thank you so much. Take care.
Miss, how long will these classes go for? The extra ones?
The compensatory sessions?
Yeah, those.
So we have a total of 6 compensatory sessions. So I have sent the schedule for this week only, because from next week, I think your whole schedule is going to maybe shift because of Ramadan starting. So for this week, inshallah, I plan on to take your sessions on Thursday, Friday, and Saturdays. If anyone has any clashes in these sessions, do let me know. Otherwise, if most of the students are going to join, then I will be conducting these sessions. So we are good with the syllabus and we move on to past year sessions, past year papers. So I think if we take like 3 compensatory sessions a week, so we will be able to do it and cover the rest of the topics which we have to in 2 weeks time period, inshallah.
Okay, miss. Thank you.
All right, take care. Allah Hafiz. Bye-bye.
Allah Hafiz, ma'am.
Allah Hafiz. Allah Hafiz.
Love this.
Hafiz.
Allah Hafiz.